Hello, grade 11s, and welcome to the first lesson of the grade 11 university level course. This is in our Intro to Functions unit, and this lesson is called Relations and Functions. It is basically a definition-based and understanding-based lesson with just ways to figure out how we know the difference between relations and functions. So some vocabulary that we need to know going on will be domain, range, relation, and function. A domain is the set of all values of the independent variable of a relation. And hopefully you remember that the independent variable of a relation are all of the x values. Okay, so anytime you're asked to find the domain, you're looking for the x values on a graph. The range is the set of all values of the dependent variable of a relation. And the dependent variables are the y values on your graph. Okay, so for an example, y equals x squared, this is the parent function or the basic function for quadratics. You can have any possible x value. If you plugged in any number into that x, you would get an answer. So for domain, what we would write, and we'll learn about this later on, but we would write the x is equivalent to all real numbers. So XER, anytime we're asking for a domain and your x's can have decimals, we will write this XER. However, with the range of this example, so range represents y's. It can be decimals, it can be whole numbers, so we write YER, but there is a restriction because the parabola, if you remember quadratics, looks like this, the basic parabola. And it never goes below 0. Remember, parabolas will always have a maximum or a minimum. So this one opens up. So we have to write the restriction that y's will always be greater than or equal to 0. And again, we're going to learn more about this later on, but it's just telling you what the possibilities are with this specific equation. A relation is a set of ordered pairs It's the values of the independent variable are paired with the values of the dependent variable. Okay, and then a function, which is what we're working with here, is a relation in which each value of the independent corresponds with exactly one value of the dependent. And it passes the vertical line test. Okay, so what this means is if we are working with a function and you plugged in an x value into the function, you would only get one possible answer. Okay, only exactly one dependent variable. And on a graph, we use what's called the vertical line test to determine whether it's a function or not. Okay, so what does that mean? If we look at these two graphs, if we chose any part of the function, so if we chose right here, and from that point you drew a vertical line, if it hits the function again, then it is a relation. It's not a function. Okay, this fails the vertical line test. Okay, remember, each x value can only have one possible y value. This one has two. When x is -2, there are two possible answers, so this is not a function. If we do the same on this parabola, so if we choose this point here, draw a vertical line, it never hits the line again. So that means that this is a function, and it passes the vertical line test. Okay, what if we're given a table of information? So we have 4 students here, Craig, Magda, Stephanie, and Amit. The ages are 15, 16, 15, 17, and they practice soccer Tuesday, Thursday, Saturday. For each of the following pairs of variables, state the domain and range, and whether or not each is listed as a function. Okay, so students and day of practice. So when it gives you an order, this is going to be your domain. The day of practice will be your range because it's telling you which one to do first. So the domains, when it's names and specific numbers, you don't do the XER because there are no decimals, especially when we're talking about names. But the domain, the students, we just write the student names. Greg, Magda, Stephanie, and Amit. And then the range is the other information that it's talking about, the days of practice. So we have Tuesday, Thursday, and Saturday. Okay, you don't write Tuesday twice, even though 2 of the students practice on Tuesday. Now, how do we determine if this is a function? Domain range. We are going to do this. We're going to list the domain, the people in domain. So Craig, Magda, Stephanie, and Amit. We're going to list the ranges. So we have Tuesday, Thursday, Saturday. Now what we're looking for is, does each domain have only one range? So Craig practices on Tuesday, Magda practices on Tuesday, Stephanie's on Thursday, meets on Saturday. So even though 2 students practice on Tuesday, each student only practices once. That means that this is a function. Okay, if we change to the ages and the days of practice, now our domain representing the ages are 15, 16, and 17, right? Do not write the repeats. In your range, the days of practice again, we have Tuesday, Thursday, and Saturday. Okay, now if we determine if this one is a function, so we have 15, 16, and 17. We have Tuesday, Thursday, and Saturday. Now, the 15-year-olds, Craig and Stephanie, practice on Tuesday and Thursday. Meg is the 16-year-old, practice Tuesday, and Amit practice Saturday. So this time you notice that the domain of 15 has 2 possible answers. So therefore, this is not a function. Why? 15-year-olds practice on 2 days, on Tuesday and Thursday. Good. And finally, the last one, determine which equations represent functions. So the first one is a linear line. No matter what number you plug into the x value, you're going to get only one possible answer, and that's easy to determine because the y is just a y. A singular y tells you it's going to be a function, so this is a function. How do we know? Because each x has one y. Okay, in the next one, this has a y squared. So that means that it's going to be a relation. Because if we were to isolate y, we would get y squared equals 9. Let's just forget about the x's. So we have y squared equals 9. That means that y is the square root of 9. Now, anytime before you've been asked what is the square root of 9, you automatically think it's 3. But if you think about it more, it's actually, sorry about that, negative 3 or 3, right? Negative 3 times negative 3 is still positive 9. So because 9, the square root of 9 has two possible answers, this cannot be a relation. This is actually the equation of a circle. And then the last one, it's quadratic. The y is singular. We know that quadratics are functions. So again, each x has only one y. Look at your y value when you're isolating it. If you don't need to square root, then it will be a function. Okay, thank you.